Okay, next presentation is refactoring. Very simple Hello World application, step by step. In fact, we have 11 steps of refactoring, and at the end, we are going to take advantage of dependency injection. Okay, so basically, the subtitle of this presentation is why dependency injection is useful. So at the end of this presentation and hands-on lab, the goal is to get the sense of why dependency injection is useful in building our application. Basically, the goal of, so basically let's actually talk about the theme. So how a simple Hello World application can be refactored in order to achieve the agility and testability. So the key aspects of any application is agility and testability. Agility is being able to change certain part of an application without affecting other parts of the application. So we are talking about maintainability. So if you have a spaghetti code, meaning everything is intertwined or mixed up, then it's impossible to change. So the goal of our application is to be able to create an application that is flexible and maintainable and agile, meaning being able to change one part of the application without being worried about the breaking the other part of the application. How can I write different parts of an application without writing a lot of glue code myself? So in many cases, you want your components. Well, in our case, in Spring Framework, we are using the term beans. We want our beans to be wired by the framework itself, by the container itself. So basically, we as a developer wants to specify the requirements of those bean wiring in the form of configuration file, either in the form of XML or Java configuration. Then we want the container to handle the object creation and wiring and configuring those beans. Okay, so that's another important aspect of the application development. The last one is a testing. How can I test the business logic without being tied up with a particular framework? Basically, you want to create your business logic in the form of POJOs, which do not have any dependency on a particular framework, so that later on, if you want to actually move your application to different framework, it should not cause any problem. So these are the aspects of the application development that you need to be concerned about. And as you're going to see later on, usage of dependency injection will certainly help in this regard. Okay, so in fact we have 12 steps. We're going to start with the Hello World, the one that you have written, and then command line argument, and from the step of 7, we are going to take advantage of Spring Framework dependency injection. Okay, and up to that point, we are going to still perform refactoring regarding the aspects that we just talked about in previous slide. Alright, so let's start with the first application. So this is the first Hello World application you probably have written the first time you learn Java programming. Very simple. So you have a main application, then you have a main method which receive arguments, then we just print out Hello World. Okay. So what are the problems of this Hello World application? First of all, the message content is hard-coded. Okay, so if you want to provide a different output, then you have to change code and recompile the code and rerun the code. Okay, so that is something that we like to refactor. So we need to have a flexible scheme for changing the message. And obviously, you can take advantage of command line arguments. Again, this is nothing really new. So here we have handle command line arguments. If the command line arguments are not present, then we just display Hello World. However, if command line arguments are present, we just check the length is greater than 0, which means that it is a command line argument. That argument represents the data, the message you want to print out. Okay, so this is certainly better than previous code. So the things we have just refactored, the code externalized the message content and then read it at runtime from command line argument. So basically you can change the message without changing code and without recompiling the code, and that certainly is a better code. Okay, what are the outstanding problem of the code then? So there are two things. The rendering logic, in this case we are going to call it renderer. Renderer is hard-coded as well. So we are using renderer logic, which is system.out.println. That is the rendering logic that we have hard-coded in our application. So the question is, what if I want to use a different renderer? Okay. For example, I want to use a standard error device instead of standard output device. Or if I want to send it out to web services instead of printing out in the standard output device. So if I want to use a different renderer, then I have to change code. Okay, so that's one problem. Now another problem is the renderer is also responsible for obtaining the message. So in this case, it actually takes the arguments, and that's the way it is getting the message content. Okay. However, if I want to change message providing logic, so how to get a message logic, to a different scheme. For example, I want to receive a message from a web services invocation. Okay. Instead of from command line argument, then I have to change code. Okay, so I have to change code so that I am getting the data from a web services instead of command line argument like from args. Okay, so changing how the message is obtained means changing the code in the renderer. So those are two issues in the code we have just seen. Do you agree with that? So that's something that we need to refactor. So the areas for refactoring include, we need to separate out this rendering logic, meaning renderer, and message providing logic. We're going to call it message provider. So these two logics should be separated out from the application so that when we need to change a rendering scheme or message providing scheme, then rest of the code do not need to be changed. Okay, so let me just repeat what I just said by reading this bullet. Rendering logic should be in a logically separate code from the rest of the application. So basically what we mean is that we want to encapsulate the rendering logic into someplace else so that we can change the rendering logic without affecting rest of the application. And the same thing can be said for message providing logic as well. We need to have message providing logic in a logically separate code so that rest of the code do not need to be changed. Okay, all right. Okay, so that is the next code that include those two refactored aspects. So here we are going to decouple messaging provider logic and the rendering logic. Okay. So we are going to have a separate class that captures message providing logic. We are going to call it Helloworld message provider class. Inside message provider class, we are going to have a method called the getMessage. So basically, we can capture message providing logic inside this class. Okay, and rest of the code, as long as they're going to call getMessage, those code do not need to be changed. If I change the implementation logic of getMessage here inside the getMessage method, I can use a web service, I can use a RESTful call, I can use the SOAP-based call, I can talk to the database, so I can implement any logic I need to in order to get the message, okay, without affecting rest of the code. Okay, so let me just repeat what I said by reading this bullet. Encapsulate message providing logic in a separate class. It will decouple message providing logic, this logic, from the rest of the application. Does this make sense? Okay, now we want to do the same thing for message rendering logic. So we are going to create renderer class. So here we're going to capture the renderer logic in the form of a class called the standard out message renderer logic. Okay, So inside this renderer, we can implement. So we have a render method. So inside the render method, we can implement any rendering logic we want. So here we are basically get the message from the provider class. Okay, and then here we are using standard output println statement. But we can change this this logic, renderer method logic, to use web services, or we can render maybe to the database, so whatever logic can be implemented inside renderer method. Now let's talk about the message provider. So in order to render, you have to have a message. So here is using Helloworld message provider class. So here is going to have this Helloworld message provider object to be set. I mean, it has a setter method. Okay, so this setter method will be called by some another code in the application. So it will receive this Helloworld message provider object. Okay, and that will set this message provider variable, and that variable will be used to call the get message. So in this case, message renderer has a dependency on this message provider object. Okay, so this message provider is the one that we have written here. Okay, so this is an example where an object has a dependency on another object. So in this case, we have standard output message renderer has a dependency on message provider object. Okay, and this dependency object will be given by someone else through this setter method. Someone will call this setter method to provide this hello world message provider object. Okay, all right. Now then we have to have a launcher. Well, this is the business logic that creates and uses the message renderer. So in this case, basically we created message renderer object and message provider object, and then from the message, the renderer object, it's going to call set message provider and passing message provider object. Okay, so now message renderer should have an access to message the message provider object, and then renderer can call render method. Okay, so this is the logic where message provider dependency object is set to the message renderer object. So just to repeat, in this case, message provider object is a dependency in the message renderer object. So the dependency object will be set into the target component, target object, in this case message render object, through this setter method. Does this code make sense? Okay, so let me actually talk about the things that we just have refactored. So message provider logic and message renderer logics are now separated out from the rest of the code. So they are in fact encapsulated so that we can change the message providing logic. So message provider logic can change without affecting rest of the application. So in this very simple application, rest of the application includes standard message renderer class and launcher class. So you can think of launcher class as a representation of your bigger business logic. Same thing can be said on message renderer. So message renderer logic can change without affecting the rest of the application. So instead of using standard output device, I can actually use web services for the rendering, or I can write it to the database and things like that. Okay? Questions up to this point? Okay, now let's talk about the outstanding problem of the latest code we have. So if you take a look at the standard out message renderer class, we are using hello world message provider class. In this case, we have hard coded this hello world message provider class. Okay, so if I want to use a different message provider in the message renderer, then I have to change message renderer. Okay, so what if I want to use goodbye message provider instead of hello world message provider? In that case, I have to change the standard output message renderer class. So that is an outstanding problem. We need to refactor. Okay, so the areas of refactoring here includes rewriting message renderer and message provider in the form of Java interface and their implementations. And the user of the message renderer and message provider uses these interfaces as reference type. Okay, so let's take a look at an example. So that is the next step. So here we are going to still provide this decoupling, but instead of using class implementations, we are going to use interface. Yeah, so far we are not using any of the Spring Framework features yet. Okay, so these are all standard Java concept. Okay, so message provider logic is now using Java interface. So we are going to have a message provider interface, and it has a single method called the get message method. And then we have a particular implementation of that message provider interface. So this is the one that actually provides the implementation of get message. Okay, so this is a message provider logic is now have interface and a particular implementation, or it could have a multiple implementations. Okay, same thing for message renderer as well. So message renderer will have these two methods. It certainly needs a render method, and then it does have a setter method where message provider object is injected through the setter method. Now take a look at message provider. We are using interface rather than a particular class. Okay. Okay, so now the standard out message renderer class will implement message renderer implementation, the interface. Okay, so here everything, the reference type is all using interface. So message provider, this is an interface rather than a particular implementation. And the render method also using the Java interface as a reference type. Okay, so rather than using a particular class object, is using message provider interface type, and you call the get message. And for setter method, same deal. It actually uses a message provider interface. Okay, so now the code is using interface as a reference type, as a variable type, as well as argument type. So it frees this code from using particular implementation class. Now in the launcher code, we also using interface as a reference type. So we created standard output message renderer, but we actually capture as a message renderer interface type. Same thing for message provider interface type. Okay, so you can see we are all using interface type. So basically what we have refactored is that if I want to use a different implementation, basically I provide a different implementation here, but I don't have to change code in here. This code does not have to be changed because it's using interface type. Okay, so what we have refactored is that message rendering logic does not get affected by the change of message provider implementation because it uses the message provider interface as a reference type. So that's what I just talked about. Okay. Okay, outstanding problems. So you can see in the launcher code, so what we have done was basically we don't have to change this code if you want to use a different implementation of message provider. This code does not have to be changed because we are using interface. However, in the launcher code, we are still specify the actual class, standard output message renderer and Helloworld message provider. So if I want to provide a different implementation of this message renderer and message provider, then I have to change this main application launcher code. Okay, so we can further refactor. So basically, instead of specifying the class right here in the code, you want to use a properties file or XML file where we are going to read the name of the configuration, name of the class, and then we are going to create an object from that class. We are going to create the class object from that the properties file. So that's basically the next area of refactoring. So we want to create a simple factory class that reads the implementation class names from properties files, or it could be XML file, and then instantiate them during runtime on behalf of the application. Right, so that is actually something we're going to actually factor. So let's actually do exercise 1.4. So basically what we are doing is, we're going to just run these applications and then just to see how things work. Right. All right, so as I said, you are going to download the zip file. So you're going to unzip it. I have already unzipped it, so it should create oh, this is a hello world. So let me see, hello world. So this hello world zip file, so you want to unzip it, jar xpf, and you can use any unzip utility of your choice. And now let's actually read the lab documentation. So on the labs, in my case, is hello world, and take a look at the index HTML5. So this is a lab documentation, and we are going to do step 0 to 4. So those are the things that we have done so far. Okay. So here we are going to just run the application because there is nothing much to look into. So usually I recommend you guys to create a Java working set, because we're going to have a lot of sample applications. So having a working set as the top level folder is actually useful. So I'm going to say Spring for Hello World. Okay, so create working set folder. Then you want to import all the sample applications from the hands-on lab zip file. So once you unzip the zip file, it contains a samples -maven or samples directory. Okay, so make sure you are expanding Maven. So you don't want to import existing project from workspace. Instead, expand Maven and then select existing Maven project. Okay, because every sample exercise projects are provided in the form of Maven project. So make sure you select existing Maven project. And next, then you're going to browse into that directory. So in my case, I'm going to go to labs. So on the labs and hello world. So hello world as a samples directory. So just click sample and OK. And then you're going to import all the sample applications. Okay, and click finish. Okay, so I have all the sample application has been imported. So we're gonna do from 0 to 4. So basically, when you run the application, right click the project and run as and Java application, and it will just then you want to select the main application is the class that contains a main method. So you can just type main, and then you should select this guy and OK, and it will just display hello world. Okay, and the same thing for these guys, a decoupled and interface. So when you run the application, again you select the main application, and then it will just display hello world. The decoupled, I want you to actually focus your attention to these 3 and 4. So those are the ones that actually requires most attention. And you can see main application in this case contains this logic I talked about in the slide. Okay, and this is a message provider, and this is the message renderer. Okay, and the next one is using interface. So here you're going to see the message provide interface, which has a get message method, and renderer interface contains render method, and set message provider the method which takes the message renderer interface type. And then we have main application is now using these 2 interface types. Okay, so these are exactly the same code that I explained in the presentation using slides. So I'm gonna actually let you guys to take a look at this code, and feel free to modify this code and see what happens. I mean, so far there is nothing really complicated, and this is all Java thing rather than Spring framework. Okay, so hopefully if you understand the concept of Java interface, this should not come anything surprising. Okay, but I'll let you guys just spend about 10 minutes to write this, to play around this code, and we'll move on to the next refactoring, which involves in the later phase of this refactoring will include dependency injection. Okay. Okay, so the things that we still need to refactor is that we like to actually have these classes to be specified in a property file so that application can read the names of those the classes and then create those class objects during runtime, so that the application do not need to be changed. The only place that we need to change is in fact the properties file. So that is something that we'd like to do as a next step. Okay, so that is the next one. So we are going to decouple the names of the application into a property file through what is called the factory class. So basically, this is a factory class that you are going to write. Okay, yeah, don't worry about the details here. So this is just an example of your own factory class where you are going to read a file name called applications.properties file, and then you're going to read the name of the renderer.class and provider.class. So you're going to have these two strings captured from applications.properties file, and then you're going to create a class object. So in Java you can say class.fullname, then you provide the name of the class, and then you can call new instance. Basically you get renderer object and provider object by using this class.fullname and new instance method. Okay, so here basically and then you're going to have a static method that actually create the message support factory class. So that is, this is your class. Okay, so this is the way that we create the our factory class object. Okay, and then we have an instance of it. Okay, all right, so basically the key point in this refactoring is that we read the names of this renderer class and provider class from external application properties file. Okay, and then we create this class object during runtime. That's the key aspect of this refactoring. Okay, now the launcher code, okay, doesn't really have to specify the names of the provider class and renderer class hard-coded. Instead, it will read, it will take advantage of this message support factory class, get an instance of it, then it's going to read the renderer class and then get the object. So basically by calling get message renderer method, it will get the renderer object and it will get the provider object. Okay, so what we have, so this is the application properties file. So here you are going to specify the names of the renderer class and names of the provider class. So by changing this configuration file or properties file, you can use a different renderer class and provider class without forcing the change of your Java code and without recompiling the code. It's certainly, so this is the improvement. So areas refactor. So this is what I just said. Message provider implementation and message renderer implementation classes can be replaced simply by changing the properties file. And there is no source code change required in the launcher code, even when different message provider implementation class and different message renderer implementation classes are used. Okay. Okay, so those are the things that have been refactored. What about the outstanding problem? The outstanding problem is that you still have to write this a lot of glue code yourself to assemble the application together. What it means is that you have to write this factory class yourself, message support factory class. Okay, now if there is a library that you can use, then you can certainly use the library instead of writing our own message support factory class. And Spring Framework actually provides a factory class that does exactly that. Okay, so that is the next area of refactoring. So we are going to take advantage of Spring Framework factory class. It's called the default listable bin factory class. Okay, so you can think of this default listable bean factory class that comes with the Spring framework is a bit more generic and more powerful version of your own custom support factory class. Okay, all right, so we are going to replace our custom message support factory class with a Spring framework default listable bean factory class. Okay, so that is the next step. So far, even in this step, we are not using dependency injection yet. Okay, so we just happen to use the Spring Framework factory class as a library. So here, we are going to call get Spring Bean Factory method, and here we are going to use the Spring Bean Factory class. So the actual logic of this get method, get Spring Bean Factory, is not important, but it returns what is called the Bean Factory object, and then we can call get bean method of the factory object by providing the name of the renderer and by name of the provider. So the only thing we have done in this case is that we basically replace our custom glue code called the message support factory using by Spring's built-in factory class, because Spring happens to have this kind of factory class, which is a lot more powerful, by the way, than our own message support factory class. So we gained much more robust factory implementation with a better error handling and fully decoupled configuration mechanism. Okay, so that's a good thing. We don't have to write our factory class anymore. We can just use a library that comes with a Spring framework. Okay, so in this case, Spring acts as no more than sophisticated factory class creation and creating and supplying instances of classes as needed in this case. So we are not really using the power of Spring framework. It just happened to use the library of factory class that come with the Spring framework. Okay. The launcher code must have knowledge of message renderer's dependencies and must obtain the dependencies and pass them to message provider. So this is called wiring. I want you to actually focus on this aspect. I'm going to actually show the code. What it means is that you still have to inject an instance of message provider into the implementation of message renderer yourself. Okay, what it means is, so let me, basically, if you take a look at the message renderer class, so message renderer class still have to have this message provider object to be injected by someone else. So it has a setter method. It has a setter method, and this setter method will be invoked by, in this case, launcher code. So launcher code will actually call set message provider, setter method of the renderer passing message provider object. Okay, so that is still something that is being done in the code, meaning the setter method has to be provided in the target object, and then somebody has to inject it. Okay, so that is the area that is still we still need to do it, even though we are using properties file. Okay, so that is the so this is the outstanding problem I just talked about. The launcher code must have knowledge of the message renderer's dependencies and must obtain dependencies and pass them to message renderer, meaning it has to get an instance of message renderer, then it has to call the setter method of message renderer. Let me repeat, maybe I mixed up, so let me just repeat again. The launcher code still has to have an instance of message provider and then inject it into message renderer through the setter method of message renderer class. Okay, all right, hold on a second, someone mentioned, okay, so we just talked about this outstanding problem. Okay, so now we are moving into dependency injection feature of Spring Framework. So the areas for the refactoring includes the usage of dependency injection of the Spring Framework. Okay, so what we can do is that we can let the Spring Framework dependency injection container to handle the wiring. By wiring, I'm actually talking about Spring Framework create the message provider object and then inject into message renderer object. Okay, so we want the Spring Framework to perform the injection rather than we perform the injection ourselves. Okay, now how can we instruct the Spring Framework to do this injection? We provide a configuration file. So in the configuration file, we specify dependency injection requirement, indicating that message renderer object has a dependency on message provider object. So as long as you specify that configuration, then it is the responsibility of Spring Framework dependency injection container to make sure that dependency injection dependency object gets injected into the target component, target object, in this case message renderer object. Okay, so let's so exercise 5 and 6. Yeah, so basically we have not done this dependency injection yet. Okay, so we are basically talking about 5 and 6. So again, we are not still using the dependency injection yet, so that is the next step. Okay, so basically I want you to just run the code, and it actually get the same result, hello world. Okay, and the code is pretty much the same. Okay, and this one is so this one is using the, again, let's run the code, and then main application, and then it will just display the hello world. Okay, now you can see a lot of debug messages from Spring Framework because we are using Spring Framework library. Okay, even though you are not using dependency injection. So if you take a look at the code, okay, we have if you take a look at the main code, okay, so we have we are calling this get bean factory method, and again get bean factory method we are calling default listable bean factory class, okay, which is basically from Spring library. So these are all from the Spring library, and the bean factory is also representation of what is called the factory class. So that, once you got the factory class, then you can call the again bean method to have an object of renderer. Okay, so here the configuration file here is yeah, so basically this is the code that I mentioned in the slide 5 and 6. Let me just move on, because I like to actually move on to dependency injection as soon as possible. So let's actually move on to dependency injection, and I'll let you guys actually perform this exercise 5 and 6 later on together. Okay, so we are going to use a dependency injection in this case. Okay, so the instruction. So let's actually talk about these areas for the refactoring. So we have to provide this writing instruction through Spring configuration. And this Spring configuration is in the form of XML file or Java configuration. So first we're going to use the XML file. So that is basically this guy, step 8. Okay. So here, dependencies of beans are specified in XML file. Okay. In our previous code, we actually talk about the properties file contains the name of the configuration file. So instead of using properties file, we are going to use XML configuration file. Okay. All right, so let's take a look at the XML configuration file. So in this case, we specify all the beans, all the project classes that are required in the application. So we have renderer bean and provider bean. So this ID, you can think of it as a name of this bean, and the class attribute specify the actual class. Okay, it should be actually full path, but assuming these classes are in the root package, then you don't have to specify the package. Okay, so the important aspect in this slide is that we have defined two bean. One is called renderer, which is the standard output message renderer class, and then we have a provider bean, which is the hello world message provider. Now, the way you can specify a dependency requirement, in this case, renderer has a dependency on provider, right? Here you specify a property element, sub-element inside the bean. Then you specify the name of the name of the field. So if you take a look at this class, you should have a message provider as a property name, and this property, meaning this field of this class, should be injected by another bean. Then another bean is actually referenced by ref attribute. So here you specify provider, and Spring dependency injection container will take a look at this bean configuration file, and we'll try to find a bean with this name, provider. And then it will create an object of this provider, and then it will perform the injection. So basically, the injection requirement is specified in a form of XML file. Is that clear? I want you to spend about 20 seconds to take a look at this XML file and get reasonably good understanding of this. Let me know if you have questions. Any questions? Okay, sounds good. So again, the key aspect in this slide is that dependency injection requirement is specified. Okay. The question from Matt: is there any scope to manage? For now, no. Okay. Yeah. We'll talk about some kind of scope things later on when we talk about Spring MVC, but for now there is no concept of scoping. Okay, so now let's take a look at the code. In the main application, basically we get the bean factory object by calling getSpring bean factory method here. And what inside this method is that it's reading this beans.xml file. This is the beans.xml file in the previous slide. It reads beans.xml file, and this class path XML application context, this class will read this XML file, and then we'll take a look at these dependencies. So what it will do is it will create an object of this renderer, and it will create an object of this provider, and then it will wire this object into message provider property of this bean. Okay, so by the time this line is done, by the time execution of this line is done, you get a factory object, and you can call the getBean method, providing the name of the renderer. Now, what's important is that you don't call the setter method here anymore, because that dependency injection is done by the container. Is that clear? So only thing you have to do is just call the render method of renderer object. Okay, so there is no setter method required, because setter method is done. The setter method is still required in the renderer class, but invocation of it is done by the Spring Framework dependency injection container. In this case, that will be done when this method, when this class path XML application context object gets created, it will be done. Okay. Question from Mukesh: is XML file Y provider referred to in the renderer bean ID in XML file? So let's take a look at the XML file. In XML file, Y provider is referred in the renderer bean ID. Yeah, so that is the way, specifying the bean ID. Okay, so basically, let's actually talk about this property element. What it means is that this class, this bean renderer class, which is the type of this renderer standard output message renderer class, has a property name called the message provider field, and that field will be injected by an object of another bean. The way you specify that another bean is using ref attribute by providing the name or ID of the bean. So in this case, it will have, it will actually use there is a provider whose ID is provider. So provider with the ID. So this bean will be in fact created. Object of it will be created by the container and will be set into message provider. So it is a dependency injection container's responsibility to call the setter method, not your code. Okay. Hopefully that answered your question, Mukesh. Let's see. Question from Matt. In these cases, if I understood, we don't need to get method, just a setter method. That is correct. Okay. Yeah, we just need a setter method in the renderer class. Okay. All right. So we are witnessing the first usage of dependency injection, scheme that is supported by Spring Framework. Okay. All right. Okay, so the things that we have refactored. The main method now just obtains message renderer object and calls render. It doesn't have to get the message provider bean and then call the setter method of it. It does not, oh, so let me just repeat again. It does not have to obtain the message provider bean and set the message provider property of message renderer itself. Meaning it doesn't have to call the setter method of message renderer itself anymore, because that is performed through Spring Framework dependency injection. Is that clear? Okay. So the things that we have done so far, note that we did not have any changes. We did not have to make any changes to the classes that are being wired together. And these classes have no reference to Spring Framework whatsoever and completely oblivious to Spring Framework existence. Meaning, your classes, your business classes like renderer and provider classes do not implement Spring Framework interfaces. They don't have to extend the Spring Framework dependencies. They are basically plain POJOs. Okay, moving forward. Now, we have used dependency injection scheme of Spring Framework using setter method. Okay. Now, dependency injection could be done through constructor method rather than setter method. So that is the scheme we are going to explore in step number 9. Okay. So in order to use constructor method, instead of using property field, you are going to say constructor arg. So in this case, this provider object gets created and then injected into this renderer object through the constructor of this class. Okay, so as we are going to see later on, when an object gets injected, you can specify either constructor method or setter method. Okay, so example we have seen so far was using setter method. Now we are using constructor method. So if you want to use a constructor method to get injected, in this case renderer should have a constructor method. So this is an example. So in this case, renderer should have constructor method to get message provider object to be injected. Okay, so instead of a setter method, you can use constructor method to have an object to be injected. That's all. Okay. Okay, so the areas refactor. So we were able to specify wiring requirements in XML. Okay. Now the thing is that usage of XML for specifying these beans and their dependencies could be too much coding, and so XML in general is losing its favor these days. So what if there are too many wiring requirements that need to be specified in XML? So in our sample applications, we have only 2 beans, and there is only one dependency injection. There is only one dependency requirement. But what about there are, let's say, thousands of beans, and these thousands of beans have the dependency injection requirement? Then specifying those beans and dependency requirement in XML could be too hairy. Okay, so declaring wiring requirements among beans could be unmanageable if there are just too many in XML. So XML is in general is less preferred these days compared to Java configuration. Okay, so the next refactoring is we want to use a Java annotations rather than XML to specify these beans and their dependency injection requirement. Okay. All right, so before we move on, let's do exercise 8 and 9. So let's take a look at the exercise 8 and 9. So here we have an XML file. Okay, so here we have a beans.xml file. So we have a beans.xml file, and so as you can see, we have specified a dependency injection, and this is using a setter method because we specify property here. So if you take a look at the message renderer class, okay, message renderer class, this is interface. We have a setter method here, and then we have the standard message renderer class. You should have a setter method. But key point is that in the main application class, we do not have to call the setter method anymore. So that is a key refactoring aspect over here. We basically get the renderer object and we just call. Okay, because by the time this is done, So we are reading beans.xml file using class path XML application context method from Spring Framework. By the time this is done, okay, beans.xml file is read and all the dependency injection have been performed. Okay, so we call this guy get bit factory if this line is done. So basically we invoke this guy. By the time this is done, we should have a factory object that represent all the beans, and then dependency injections are performed. So we should be able to call the render method directly. Okay, so that is the step 8, and step 9. Step 9 is this is a case we still have the this beans.xml file, which so here we specify constructor arg rather than property field. So when you're using constructor arg field, that means I want to get this dependency object to be injected through the constructor method. So if you take a look at the standard up renderer class, you can see we now have constructor method receiving this message provider object. Is that clear? Okay, so I'm going to give you guys about 10 or 15 minutes to do exercise 5 to 9. Okay. Okay, so now we're going to actually move on to what is called auto-wired annotation. So, we're going to actually talk about this auto-wired in a bit more detail in our next presentation. Okay, but here I'm going to actually let you have some exposure to auto-wired, because this, for the sake of completeness of this Helloworld application refactoring. So here, instead of having setter method, we can say auto-wired and this message provider. So auto-wired is basically asking the dependency injection container to set this field without you providing the setter method. Okay, so this is a lot more convenient than writing setter method. So these are commented out, and then you just basically say auto-wired. So what you're saying is that you're basically asking dependency injection container of Spring Framework, find the type of message provider object, okay, and you find the class that is a type of message provider first of all, and then create an object of it, and then inject into message provider. So that's basically what you're asking dependency injection container to perform, okay, without you providing a setter method. So setter method is kind of implied in auto-wired. Okay, so that is now there is no need to specify that wiring requirement in the XML either. So we don't have to have this setter method, and we don't have to specify that dependency injection requirement in the bean configuration. So here the only thing we specify is just a bean, renderer and provider, and there is no property field, there is no constructor arg field, because what we have said is that by using auto-wired annotation. Okay, now if you're using XML configuration and if you want to use this annotation, then you have to have this enable usage of annotation. You have to say annotation config element pre-configured. Okay, but the key point in this case is that there is no message provider property in the renderer, because this is done, writing is done through the auto-wired annotation. Okay, so the things that we have just refactored, we were able to specify those wiring requirements, meaning dependency requirements, right in the source code using auto-wired annotation. Okay, however, you still have to declare all the beans in XML5. So the bean, as we're going to talk about in a bit more detail, so bean basically indicating I want an object instance of this. I want object instance of this. So we have basically have an indication of creation of 2 bean object instance. But dependency injection, you don't have to specify an XML file because you specify using auto-wired. Okay? So that's what I meant by here. You still have to declare all the beans in XML file using bean element. Okay. Now the areas that we still the issues is that what if there are too many beans we need to declare. So having all these beans to declare an XML file is still a chore. So we save the dependency injection requirement in XML file, but we still have not saved the effort of for specifying all the beans. Okay, so the next area of refactoring is that we want the Spring Framework to auto scan the package and find all the beans and create an instance of those beans. So that is basically auto scan feature. That is the next refactoring area. So we want Spring Framework to auto detect all the beans and create instances automatically without us specifying those beans in the XML file. Okay. So that is the next step number 11. So here we're gonna use auto scanning. So how we specify auto scanning? Before we move on, let me actually see